Hey everyone, thanks for joining. John here, senior software engineer with 10 years of experience. I'm the lead maintainer of Latterly.io, which is an open source website, social community, and educational platform that helps you land your first or next programming role. And today, we're kicking off a Leetcode Marathon. So let me give you some of the background behind this. I'll share my screen. First of all, here's Latterly. I recommend you go and sign up for free and join the Discord. A bunch of the information that we'll cover is in the backlog. So here is the system design issue. So a system design guide has not yet been included on the blog. This is one of the reasons you should join the Discord, is you can get to hear about stuff like this, even if it's not yet on the website. You can see we're mentioning Excalidraw over here. So let's go use Excalidraw. So here is some of the background motivation for today. I was using interviewing.io, which I use for my FANG interview loop preparation. I have FANG interview loops coming up. And I got a bit of a reality check, which is great. That's the whole purpose I use it. I completed a coding round. I got to an optimal solution, but it required multiple hints. And so the interviewer appropriately told me that it was a coin toss if this would have been a pass in a real interview setting. And that was a bit of a reality check to me, and I said I need to up my coding round game. And so I realized that I haven't done a full standard kata. Leetcode kata is blog article number 3 on the Latterly blog. This is the standard coding round preparation recommended by Latterly. And I haven't done a full kata. So I've been up to problem 8 or 9. I think I got up to problem 8. I don't think I've completed path sum. So how am I addressing this reality check? 2 parts. One is we're going to get all the way through the kata, hopefully do that today. And 2 is we're going to apply some of the advice from this based interviewing.io coach, who is a real interviewer at a FANG company. That's one of the benefits of interviewing.io. I'll give them a quick plug. You can have anonymous interviewers with real engineers from these companies. So this was a FANG interviewer. He had a code name, Meta something. And his advice boils down to these 3 tips that I have here. And I will be doing both. So the question is, should I do the Latterly thing, or should I do the thing that he recommended? Why not do both is the answer. So we want to raise the bar to make sure that we're well prepared, okay? And so here is my summary of his tips. One, basically it's use Leetcode, use Leetcode. So he pointed me to the Leetcode 150. So we'll be building on this, the Leetcode 150. And he said, look at the top half of the categories. So we have arrays, 2 pointers, sliding window, and so on. He said, I don't know exactly where the slice is. Maybe it's going to be somewhere around backtracking tries or priority queue. He gave 3 bits of advice, and we can take the union or the intersection of that advice. I'd prefer to take the union. It's more conservative, right? But he said one of his bits of advice is look at the top half of these categories, do those, and then also do intervals. That was the first thing he said. Second thing he said was do round robin of the following topics, and he gave these topical tiers: graph, trees, binary search, intervals, and then here's tier 1. Tier me, I added this. I feel like tries should be in there somewhere. So these are 2 different pieces of advice he gave. Again, talking about the union or the intersection of the advice. If we take the intersection, maybe stack is ignored, right? Because stack is not in this tier 0. Oh yeah, it is, it's in tier 1, okay? And then exactly where is the half? Does tries technically fall in the bottom half or graphs? So you can be picky if you want to, but I think we'll just do all of it. And then the third tip, really, really good tip, is this concept of freshness. And his specific rule of thumb is you don't want to go 2 weeks without seeing each of these categories. So this is, I think, a very valuable insight, which is an empirical marker on the concept of freshness. I think we all know, and the laterally Leetcode kata is created to ensure a sense of freshness and familiarity with these problem types. But I don't think I have a hard rule about the frequency of which you should exercise the kata. Or if I wrote one down, I forgot it. So the idea that you should have a 2-week cycle seems to be extremely useful. I have a mixed benefit in that my rounds will occur over the next 2 weeks. So in theory, I can just do each of these problems once. In reality, if I want some level of higher reinforcement, I should probably do these multiple times, 2 or 3 times each. So I'll be shooting for 3, but I won't feel bad if I at least touch them once. And so the goal of today, so we're having a Leetcode Marathon today. I may break the stream up. We may have 2 or 3 streams throughout the day, or it may be 1. We'll see how we do. The goal of today is to touch all of these problems once. And then, today being Thursday, today being Wednesday, I will also be trying to shoot for touching each of these groups 3 times by next Monday, basically. So we'll see if we can get there. But at least once I'll feel good about that. Okay, so that gives you the background. What else am I doing? So we're gonna do this marathon, and then I'm also gonna motivate myself with sweet treats and gaming time. So if you are in my shoes, you might think that grinding Leetcode is super hard to do, super boring, it's super hard to get yourself motivated to do it. Well, let me introduce you to sweet treats. You can basically give yourself accolades, presents, rewards at each of these milestones. And so I am gonna do a $100 Steam budget, guilt-free gaming for a day. I don't know exactly what day it'll be, but I'm gonna reward myself, and I already got a nice latte. And so you can do little stuff like that. I might go out to eat. So we're gonna get this done, and we will buttress motivation with these micro tools, okay? Unrelated topic, but I just made a diagram today, so I'll show it off. JSPaint.app, amazing MS Paint in the browser. And this is to do with job search application strategy. So I was recently asked, hey John, because I've already gotten offers, right? I don't know if you've been following along, I should assume that many of you have not been following along. My FANG loops are the last phase of my job search. So I've already gotten multiple offers. They just are not FANG offers yet. So FANG loops are typically slower. To get a Google interview, I've had Google offers in the past. So the Google interview process, it's just longer. It's just longer. Many of these permissive employers in tier 3 could even have a 1-stage interview process. So you could turn around and get a job within a week. My first offer, from being laid off to getting my first offer, which was a tier 2 offer, not a tier 3 offer, it was less than 3 weeks. So I didn't quite do it in 1 week. And in part, that's because I've been relatively selective despite being laid off. So you could get a job even quicker than I've done if you use a superpower of lowering your compensation ask. So at its core, this mental model is just a supply and demand graph. By lowering your compensation requirements, you will explode the number of job opportunities to which you're qualified and also accelerate your potential placement rate. And so I have a certain threshold of what I consider allowable. And so I've filtered out some of those jobs which may have placed me even quicker. So I'm very happy with my less than 3 weeks marker. If I had really been trying to get that number as quick as possible, I could have done better, but I would have felt a bit disingenuous because I would have been seeking an offer to which I had no real intent of accepting. The tier 2 offer, I'm genuinely happy with if FANG doesn't work out. But I have a feeling FANG can beat it. I have a feeling FANG can beat it. So that's why we are continuing on in the job search. So some of the frequency markers here, this will work for juniors as well. So some people have asked me, hey John, you're a senior, doesn't that make your job search easier? Absolutely it does. Absolutely it does. I'm fortunate to be able to say that in addition to my own experience of getting that offer within 3 weeks, I've also helped juniors land offers over the past couple of months. And so you can scale this and tune this based on your position in your career. Are you early? Are you late? Also based on your preferences and your selectivity. Do you need a job now? Or can you take 6 months or even 12 months to be more selective and find a job that you are highly targeting? Okay, let me know in the chat if you have questions on that, or you can come over to the Discord. I think I've said most of what I wanted to say there. So with that, let's dive into the code. The first thing we're going to do, just to warm up, and this idea of warming up, right? It was there in the job search. It's going to be here in our code preparation, and then we're going to apply it today. So we're going to warm up by doing problems we've done on the stream before. So section 1 of the stream will be 1 through 8. We'll see if I can remember number 8. So section 1 will be 1 through 8. These are familiar problems. And then 9, 10, 11, 12 will be problems that I have not done this job search yet. And my approach will be to time box 9, 10, 11, 12, to time box each of those to an hour. I think we can get through 1 to 8 within 2 hours, maybe within an hour, hour to 2. 1 through 8. And so the overall first phase of the marathon would then be, what is it, 5 or 6 hours? 5 or 6 hours for this first phase of the marathon, after which we will go over to Leetcode. And that is a conservative estimate. We may be done faster than that. So 5 to 6 hours, I would say, would be including breaks. Let's just call it 6 hours. 6 hours would be a conservative estimate of this first phase, including breaks. And so this may be all we do today. Nope, I'll have to do a late stream, won't I? It's a real marathon. We're marathoning it. Okay, well, I have a cold brew with me, so let me take quick advantage of that. All right, so my original plan was up to 6 hours for these 12, but I want to make sure that I get into Leetcode. Let me remind myself how many are here. 1, 2, 3, 4, 5, 6, 7, 8. So we do each of these in 30 minutes with a 30-minute time box. Then that would be 4 hours. We can do 10 hours today. We can, with the caveat that I will be taking a dinner break. And I think that's fine. So 10 hours, and then getting done is its own reward, isn't it? Getting done sooner is its own reward, because 10 hours is quite a journey. So I may be cutting some of those 1 hour time boxes even down further. Or perhaps we can just solve the problem quicker without needing to time box it. That would be nice. Okay, so let's do the lower limit. So the upper limit will be 10 hours. And then definitely that will be broken into multiple streams, at least 2, if not 3 or 4. 10 hours is, I'm not going 10 hours straight. So in the worst case, we'll be doing 10 hours. Let's say the worst case is 4 streams, totaling 10 hours. And then the best case, let's say a best case estimate would be if I complete, maybe I've just seen a bunch of these and I just know a bunch of these, and then I can knock out problems in 30 minutes, yeah. And then also my best case time box here, 1, 2, 3, 4. Let's do 1.5 hours for the first 8. And then 1, 2, so 3.5 hours, I think, is the best case for these 12. And 4 hours is, I really think, the best hour. So between 7.5 and 10, between 7.5 and 10. I think that's the estimated range. 7.5, we could do maybe as little as 2 streams. Probably that's going to be 3 streams too, as well. So probably 3 or 4 streams today. There's a small chance of 2. I frankly doubt it. Matthew says, can you explain your website? I think you're referring to latterly.io. So a couple of the features that it offers, I'm not going to take too long because I could spend an hour going through all the features of the website. But at a high level, you get a free checklist. Let's see, I need to log in. So you get a checklist that teaches you to code and build a portfolio step by step and then land a programming job. Okay. So that's probably the main feature of it, besides the community itself. A lot of developers think that learning code will get them the job, and they neglect social networking. They neglect professional networking and social community. They think these words are like airy. They see a Discord server and they think that this is like a very boring, low value feature. I would suggest that joining the Discord is just as valuable as completing every other step in the checklist. And that's why it's the first recommended step. Frankly, I don't consider you having completed the Latterly curriculum if you are not a member of the community. And that's not for some kind of frivolous, checkboxing. This checkbox is a proxy for value that goes much deeper than the checkbox itself. And so social networking is going to help you land the job. That's it. It's going to help you obtain an interview. Does this teach only full stack? Yes, the Latterly standard curriculum is full stack. Although only full stack is a strange thing to say, isn't it? Because that includes front end, back end, Angular developer, Vue developer, UX, UI. It'll be applicable for many, many job titles. I challenge you to define a different curriculum that can be completed with similar time and effort that will allow you to be qualified for more job titles. It is full stack, and by virtue of being full stack, it is also front end and it is also back end. A little bit of SQL in there. Cool, so the main feature there is the checklist and the social community. Two lower features that I think are still worth mentioning. There's 24/7 chatbot support. So if I'm unavailable because I do sleep, it turns out, and even then when I'm awake, for the most part, my sessions are one-on-ones. And so I may be inaccessible, I may be working and so on. You can have a 24/7 chatbot support that is a custom GPT with a laterally tuned knowledge base. Not proper tuning, like in the ML sense, it's just pre-contextualized. In the future, I'd like to do proper tuning. Yeah, drop a note in the chat if you would pay for a tuned model, because the big blocker right now is that I would have to pay for it. Okay, and then the other thing is you can book an expert session. So lots of Latterly advice is really, really powerful and useful, but it is also optimized at middle of population, the median, the mode, the average, the central tendencies of the student population is where the guidance is given. In many cases, the best advice for you in a personalized way, in a tailored way, in a customized way, will deviate significantly from the best advice for the central tendencies of the student population. In fact, for most particular students, there is at least one thing that I would recommend to change. And that's why the expert session is incredibly valuable. Everything from where should I learn to code, to how should I learn to code, to what should I code, to should I be coding at all? Maybe I should be considering a different career path, data science, product, and so on. I've also done entrepreneurship consultations. So some people are like, hey, should I work a Fortune 500 W-2 or should I start my own company? The typical answer is you should work a Fortune 500 W-2, by the way. That's the common risk-averse answer. But there are particular factors and features of personality and experience that would make entrepreneurship more or less of a good idea for you in particular. Okay, I think that gives an overview of the site. Thank you, Matthew, for the question. So let's go to do some code. Okay, the background. I'll leave this open over here. And we'll get started with TwoSum. Number 167, where the array is already sorted. Oh, I'm not signed in. Let me sign in. I got a new computer. It's Windows 11, and it's ML training capable. So it says success, but I'm not signed in, eh? What happened there? Let me drag this off screen. Okay. Let's switch over to Python. The laterally kata have solutions in blog article number 7 for Python, Java, and JavaScript. So I will be using Python. I find it's easier for me to perform coding rounds in Python. But if you speak another language, check out those playlists, YouTube video playlists. All right, and the problem reads, given a one-indexed array of integers that is called numbers, which has already been sorted in non-decreasing order, let's find two numbers so that they add up to a target. Let me wipe out the previous solution, by the way. Oh, the Windows hotkeys are different, eh? Acclimating to my Windows machine. Okay. So we want to add them up to a specific target. Let the two numbers be called index 1 of numbers and index 2 of numbers, where they're between 1 and the length of the number set inclusive. Return the indices. So what are we returning? We're returning a list of indices. It will always be length 2. Tests are generated such that there is exactly one solution. We cannot use the same element twice. The solution must use only constant extra space. The solution must use only constant extra space. And we can see in the examples, by the fact that there's exactly one solution, we don't need to worry about duplicates. We also don't need to worry about the case with 0 solutions. So that's nice. Oh, let me also check in on TikTok. $480 likes. All right, thank you so much, TikTok. I'm using the Windows Live Studio on TikTok for the first time, so getting familiar with that interface as well. And it looks like there's a new follower. Bummer, I can't see the name. Sorry about that. I'd love to say thank you, but somehow I can't see the name of the new follower. But thank you for the new follow. Okay, so given that it's already sorted, and we want constant space, I can use a 2-pointer approach. The performance will be O of n, because I will scan every pair. No, not every pair. I will scan every element in the worst case. Okay, so we'll initialize left to 0. Right will be the length of numbers minus 1. Our exit condition on a while loop will be while left is less than right. We don't want to continue to calculate after that point because the sum of 1 and 2 and the sum of 2 and 1 is equal. We are required to provide unique answers. So the pointers switching will only give us duplicates of sums that we've already created. So we just shouldn't run those sums at all. Does that make sense? If I have the number 1, 2, and then my pointers flip and I sum 2 and 1. So as soon as the hands cross, I should just exit. So here's the left of numbers plus the right of numbers. And there are 3 possible conditions here. In pseudocode, the current sum could be above or below or at the target. So at the target, we want to return left plus 1 because we're returning the one indexed result based on the prompt. Ava Celesta, welcome on Twitch. Thanks for being here. So above is a pseudocode. What we mean by that is that the current sum is greater than the target. And what should we do if we have 2 pointers which are initialized to the ends of the array? This array is in non-decreasing order, meaning it might say 1, 1, 1, 2, 2, 2. So there can be duplicates in a row, but eventually the following element will either remain the same or increase. So what I would like to do is take the pointers and shift them to the right, but I cannot shift my right pointer to the right because it was initialized at the end. So the only option that I have to grow this sum is to move my left pointer to the right. So here we will increment the left pointer and we will reduce the right pointer. I did that backwards. We will increment the left pointer if the sum is too small and we want to grow the sum. And we will take the right hand to the left if we want to shrink the sum. Why would we shrink the sum? We would shrink the sum because the current sum is too large. Oh, I did this backwards. It shouldn't be numbers of left, it should be left of numbers. Below is a pseudocode. Let's update that. Great. Okay, 2 sum down. Three sum. One of the virtues of the Leetcode kata from Latterly is that there is a pattern level flow, a meta flow, that enables better performance, basically. It enables better performance. So 3 sum will recycle some of the mental model of 2 sum. All right, so 3 sum, the question says, given an integer array nums, return all the triplets, ijk of nums, such that ijk are distinct. They're not the same indices. And the triplet values sum to 0. Notice that the solution must not contain duplicate triplets. Here in example 1, we see that the triplets are distinct. It says the distinct triplets are -1, 0, 1 and -1, -1, 2. So the triplet, that is the whole set or list, is distinct, although the elements inside of the triplet may be duplicate. So here we see -1, -1 are duplicate values within the triplet, but not between triplets. Does that make sense? Thank you for the follow. Yeah, I'm really bummed that I can't see the new follower names. Okay, so approach, wrap, optimal 2 sum in an O of n wrapper. This requires O in squared time complexity because it only uses pointers. The space complexity is O1. So to use the optimal 2 sum that we just described, the first thing we need to do is sort nums. So now it is in non-decreasing order. This costs non-binding, non-constraining O n log n. So here I'll make an outer left pointer, which is set to 0, and my while loop, I'm scanning left to right across the whole series. I don't need to use a while loop, I'm just doing it because it came to me. It's easy. but you could use a for loop or what have you. We're scanning left to right across the entire series. You could use a for in if you want to. I wouldn't recommend that though. I think it's good to have the integer index. And so while we are in this series and we're moving from outer left to right, why do we call it outer left? Because our two-sum will have its own left and right. So this is an additional further left pointer. First thing I want to do is I want to find the complement. So here I'm taking nums, and what would the complement be? It'll be the opposite of the number at the outer left location. Why is that the complement? Because whatever value is at the outer left index of nums, my goal is to sum to 0, and I can fulfill that goal by adding this number, which I'm calling the complement, which is just its opposite. So 3, -3. I ultimately get my total of 0. So this complement will become the two-sum target. So we'll make a two-sum. We will pass it the complement. It also needs to know about the outer left index. It also needs to know about results, which we haven't yet defined. So let me go make results. In Python, I would like this to be a set because it automatically deduplicates tuples. It won't work with lists, so we need to store tuples in this result. I need to pass nums to the two-sum. And I think that's everything I need to pass. And then we'll say to do fast forward duplicates. And then we will eventually return results. So let's go down here and define two-sum. I'll take the arguments as passed and just place them right in here. So for my two-sum, the left is going to be the outer left plus 1. We want to explore the window to the right of the outer left. So I don't want to check every number every time. As I move from left to right in the outer left index, I've already explored those potential combinations. I don't need to look at them again. That would just be wasted cycles because we can predict that we've already added any pertinent results to the result set. The right is still going to be the length of nums, -1. The end is still the end, eh? We'll use the while left is less than right exit condition for reasons that I discussed earlier in the stream. Basically, whenever you invert the order of a pair, their sum remains, so you don't need to check the full series. And here I want the left index of nums plus the right index of nums. The right index of nums. Okay? If above, elif below, else. At target, add to results. So in this case, we want to add to results because there might be multiple. We're not going to immediately return. We can also see in example 2 that there might be no results, but that is still handled within this logic because this else block will only execute if a match was found. We don't need any logic inside of this else block to handle match not found. It just won't enter the block at all. So I can call this a sorted tuple. We don't need to run sort. It's going to be sorted automatically because left will always be to the right of the outer left, and then right will always be to the furthest right. If you're enjoying the video so far, tap like. That will help the algorithm send it around. Oh, real bummer. I'm seeing 7 comments on TikTok, but I can't read them. What on earth is going on with my chat widget? Thank you for the comments. Let's see if I can read them. If you can't see the live chat window, try switching the game to windowed mode. Oh, is it because I'm not playing a game and it's getting confused? TikTok, we're not playing games. This is serious. Let me comment test over there. Test is not being sent either. Well, I would just encourage you to check the link in the bio and go over to YouTube or go over to Twitch or LinkedIn. I can see the chats there just fine. I'm not sure why TikTok chat is coming through, unfortunately. Also, if I don't get to your comments during the stream, you can always go to the Latterly Discord and I will address your questions after the stream. BetSimp from Twitch says, is this for some kind of program? This is interview preparation. So are you familiar with software engineering jobs? Maybe you're still in school. This is a Leetcode problem. It's a coding challenge that will be commonly used. It's not this exact problem, but problems like this will be commonly used in big tech coding challenges. I'm pretty familiar. Okay, cool. Cool. Yeah, so it's just interview prep, basically. Technical interview preparation. Okay, so we have our sorted tuple here, outer left, left, right, but we don't want our result to have the indices. We want our result to have the values. So let's pick these out of the nums list. Great, and then I want to add it to results.add, the sorted tuple, okay? And then I want to fast forward duplicates. How will I do that? I will say while in bounds and left unchanged. So I could perturb my left or right side. Either one will work. We just need a perturbation condition. Perturbation condition, this is what we need. To continue the while loop, so that we're changing right or left. I will arbitrarily select left just because the overall mental model in the solution is to move from left to right, so it's consistent with that. And so in this case, we are perturbing left, so we will increment left. Now, how do I know that the left is unchanged? Well, this value will be changed. That's how I know. So I'll say left val is the left index of nums at that time, but later down here, I'm incrementing left. And so is it still equal to the new nums left? I'll be checking that on every iteration of this 32, 33 line while loop. So it bumps left. Imagine I have the run 111, 222. So here I'll be changing the index, but the value won't be changed. It's 222. So I'm fast forwarding those because I know my tuple is still going to include a 2, regardless of any of those. So I can just skip over the others. Does that make sense? And save myself some cycles. So that's what we mean fast forward duplicates. What does this inbounds thing mean? Technically, we can just use this while left is less than right condition. And we're going to want a similar condition up here where it says fast forward duplicates. We're going to say while in bounds and complement unchanged. Then we will perturb the outer left. And the inbounds here, again, we can just use that existing boundary condition. So the complement unchanged is currently a pseudocode. We'll come back and fix that. We'll come back and fix that, but let's finish up two sums. So I'm appending to the results when I have a match, but what about when I don't have a match? So what if the current sum is greater than my complement? So the complement is the target now. If the current sum is greater than the complement, I want to reduce my current sum, and I reduce my current sum by moving the upper hand down. And we'll do the inverse if I want to grow my current sum. So if my current sum is too small, then I want to grow it. How do I grow it? I take my left hand on this sorted array, take my left hand up. Good, two sum looks good. Let's implement this pseudocode. Complement unchanged. If complement is equal to this expression. This will always hit once by construction, but after fast forwarding, it may or may not continue to skip. All right, so less than is not supported. So nums is not supposed to be here. What's supposed to be here? While outer left is less than, I think it's just the length of nums. So the point of this is to check every element. Okay, it takes 4 positional arguments, 5 were given. This is on the solution class, so I need to add a self argument. And then here, because I copied a bad condition, it's also error in here. Let me update that nums to a length of nums. Great. And 3 sum is down. Let's go. Now we're on to longest substring without repeating characters. Wipe out the prior solution. And the prompt is pretty straightforward. Given a string called S, let's find the length of the longest substring without repeating characters. We have example 1. The output is 3, so we want an integer return. And the reason is because ABC is the longest substring without repeating characters. In example 2, this is sort of the almost worst case. There's another worst case we should deal with. But you can see they're all repeating, so it would be 1. Looking in the constraints, S could be of length 0. Which is even another kind of like worst, in a sense, worst case, but it's like an edge case is the better thing to call it. So it's an interesting edge case where you can actually get less than 1. Your mental model might be, oh, if they're all repeating, that's the limiting case. And if they're all repeating, the integer result would be 1. But actually there's a further limit where the string has no characters at all. So we will initialize result to 0, and then we'll eventually return result. And do something with S. Okay? So intuition says if S has no repeats, longest substr is length S. So worst case time complexity is O of n. I may need to check every letter. Okay, so you have the time complexity. What about the space complexity? Well, what I want to do is maintain a list of characters that I've seen so that I can know if I am facing a duplicate. For space complexity, I must collect seen characters so that I can detect a duplicate. In the worst case, we collect O(n-1) having been seen. So you could say it's asymptotically O of n space complexity. We are also bounded by English letters, digits, symbols, and spaces, which can define some constant space, constant upper limit. Okay, so you could characterize it either way. You could say it's O of n, or you could say it's bounded by that set, whatever that is. So letters and digits, and then I don't know what the set of allowable symbols is. Okay, so what do we do with this stuff? We need a scene. We need something for scene. What do we want? A hash map, a set, a dictionary. Let's do a set. Let's do a set because I don't care about the index where it was seen. I don't care about the index where it was seen. So I have no value that I need to store with respect to my key. So I have no need for a key value pair. I just need a key only set, which is a set. It's the simplest structure that accomplishes the goal. Okay, and we can do for in range. The range here will be the length of S. We're just going to check every character here. So for IDX in the range of length S, cur char is IDX of S, right? If seen to do. And then what if we haven't seen it? If we haven't seen it, we want to scene.add cur char. So now we say, I have seen you now. I have seen you now. And then we want to get the cur substring length. It's just going to be the length of current substring. Let's see. I don't need to maintain this substring. I can just look at the right and the left. So I need to maintain a left pointer, which will initialize to 0. And here I can say the current substring length is wherever I'm at minus left plus 1. You need to add the 1 because what if they're both pointing at the same letter, like 2 and 2? You still have a length of 1 because 2 and 2, the length of your string is 1. So you might say 2 minus 2, but then you need to add an extra 1. It's an off by 1 thing. Okay, so IDX minus left plus 1. And then the result we will update. It's going to be the max of whatever it was or the current one. All right, so I think the only thing remaining is this if seen thing. So what if we've seen it? What does it even mean if seen? What we should be saying is if the current character is in scene. That's the way we say that it has been seen. And so if it is in scene, we need to fast forward left until the dupe is eliminated. This is called a sliding window, by the way. So you can think of like a caterpillar or an inchworm or a regular worm, I guess. It's leading with the front. Oh, I ran into a duplicate. Do I move my forward pointer back? No, I shouldn't do that because if I move my forward pointer back and then I try to proceed, I just keep running into the wall. I've basically created an infinite loop, right? So the right thing to do is not to move my forward IDX backwards, but instead to increment my left until that duplicate is no longer a duplicate, and then I can continue, sort of like an inchworm, right? And you can see how this supports the boundary cases where they point at the same person, the same index, or it could potentially grow across the entire string. Hope that made sense. If that made sense, drop a like on the video. Thank you so much. All right, so how do we fast forward left? Well, we should not say if cur char and scene. We should say while cur char and scene. And while cur char is in scene, we will scene dot remove the left. And then we will increment the left. So while the current character based on the right is a duplicate, we're going to keep moving left up and eliminating those letters and saying, I haven't seen it, I haven't seen it, until current character is no longer a dupe. It's no longer in scene because it was deleted by left. And that's how you do it. Beats 97.22. What up? Love to see it. This is analyze complexity. Is that new? That looks new. Okay. Now we're done with longest substring. Next one will be the linked list cycle. Yeehaw. I've got a weird timestamp on my video. How long has this been? I don't know how long we've been streaming. 10:40 a.m. Okay, not that long then, eh? 40 minutes maybe, something like that. So let's get rid of the prior solution and read the problem. So given head, the head of a linked list, and based on the example panel on the right, definition for a singly linked list, we can say that the linked list is singly linked. It has a next pointer, it doesn't have a previous pointer. So we're given a head node to this list, and we want to determine if the linked list has a cycle in it. Well, if there is a cycle, what does that mean? It means that if you keep following next, you eventually get back to that starting point, that head. A merry-go-round, like a roller coaster that never stops. We have a picture in example 1. You can see 204 creates a cycle, or it's -4. 2, 0, -4, 2, 0, -4. Right, so you might not ever get back to head, but you have some cycles somewhere in there. And you can never exit the loop. You never exit the loop. So it becomes tricky to detect, because what you might want to say is, if you have a loop, we'll just check the whole thing. But if you check the whole thing, you invoke an infinite loop. So you can never actually check the whole thing by just running through it or copying it to an array, for example. The copy operation would time out. So we just want to return true if there is a cycle, otherwise return false. So how are we going to do this? What you could do is you could keep track of every node that you've visited. So you could say, oh, I've seen 2 before, and now here I am at 2 again. Therefore, now let's escape this loop and let's just immediately return true. There is a cycle because I'm back where I've been. That would work, but it's not memory efficient, because you're potentially growing a really big store in memory of all these nodes that you've seen. What if that list was much, 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 much longer? So another more clever thing that you can do is you can actually send 2 pointers down this traversal and have them going at different rates, so that one is moving faster, and if they ever collide, there must have been a cycle. Think of like people running track. You have a slower person, a faster person, and they just run, and they just keep running. Well, eventually the faster person will lap or catch up to the next pass on the track. And so that is a cycle detection by collision detection. And that's what we'll do with 2 pointers. That is a memory efficient approach. This problem says it's easy. Easy is intended for if you just do that inefficient solution of keeping a copy. What we're doing is a more clever solution that's actually harder than an easy problem. So intuition, we will check with fast and slow pointers. This takes O1 space complexity. Time complexity is O of n. In fact, it's going to be more than O of n. It's like closer to O2n, because you're guaranteed that you'll need to go through that loop more than once. The best case would be On plus 1, where you go through the list, and then you go one more step and you collide there. That would be the best case. The worst case is much later, the collision could occur. So here we can say fast is 0. And no, fast should be head. So we'll point at head. So fast is head and slow is head. And we'll say while fast exists, because look at line 8. There's a little tricky nuance. Line 8, head is optional. They could just pass you a null. That is a bit of a trick question there, isn't it? But we'll say while head exists, because fast is pointing at head, and so while fast exists, and fast.next, so while there's somewhere to go, and while fast.next. So this is called fast because it will step forward twice, and the slower one will only step forward once. So it's moving twice as fast as the slow one. Something fun about that is when the fast node touches the end of the list, the slow node is right at the midpoint. So that's extremely convenient in some other use cases. So while it's allowed to step forward twice, it will do so. While it's allowed to step forward twice, it will do so. And slow will step forward once. Slow does not need to have any null checks on it because it's always lagging fast. So if the null checks from fast pass, slow is good to go. Quick reminder, if you're on TikTok, I'm not able to see the comments today. Sorry about that. But you can go to YouTube or Twitch. The link is in my bio, and you'll be able to drop a comment there. You can also join the Discord at latterly.io. Okay, so fast and fast.next, right. So now we just need to see if they collide. If fast is slow, return true. There's a collision. And how do we know that there's not a collision? How do we know that there's not a collision? Well, we will eventually organically exit the loop because fast will have run into some sort of a null pointer or an end, basically a null pointer. Or in Python, it is a none value. It's basically a null pointer. And so if we get down here at all, that means there is a termination to the loop. If there is a termination to the loop anywhere, then there's not. If there is a termination to the linked list anywhere, then there is not a cycle. Great. On to the palindrome linked list. A little bit more fun here. Once again, we're given the head of a singly linked list, and we want to return true if it's a thing and false if that thing isn't a thing. What's the thing this time? This thing is a palindrome. It's not a cycle. So we don't care so much if there's a cycle now. We care if the linked list is a palindrome. It's still a singly linked list. What is a palindrome? A palindrome would be any single digit, letter, symbol. 1 is a palindrome. And then any repeated character, symbol, digit. So 11, 22, AA, BBB, these are all palindromic. And basically, it's a mirror version of itself along the midpoint. So there's also items like 1221 or 1331 or 1441 or 1TT1. You can mix letters and numbers. Or DAD or MOM. Mom, Dad, and Race Car are all famous palindromes. Chandu on Twitch, how's it going? It's going well. Thank you for being here. Thank you for being here. So we know what a palindrome is. We're given this head node. How are we going to go find it? Well, we used 2 pointers to detect a cycle. So maybe we can use 2 pointers for a palindrome. How would that work? Well, if we do fast and slow pointers, whenever the fast node hits the end, the slow pointer is at the midpoint. So maybe I can use that midpoint to then check that second half of the list against the first half of the list, there's one wrinkle here. I need to flip that second half. So that if I look at the word race car, R-A-C-E-C, so the CEC condition, I either need to get 2 pointers to the middle and then move them opposite directions, but I can't do that because I have a singly linked list. It only goes next. There's no previous pointer. So I could create a doubly linked list. I could copy it. But if I do that, now I'm taking O of n space complexity, which is kind of defeating the whole purpose of the pointers. The pointers allow me to have constant space. So I don't want to traverse backwards. What I'd like to do instead is not copy anything, but actually mutate the second half of the list in place. I can mutate it in place. That has no memory overhead. So if I flip it in place, now I can have a new pointer at the original top and this pointer from the middle, and they will compare letters concurrently. And they'll either be the same or not, and that will tell me if it's a palindrome. So when that race car flips the ECAR at the end, it flips it and now it spells race. So I can have a new pointer to head and the middle pointer on the flipped second half, and they're gonna go R-A-C-E. Oh, it's a palindrome. That's what we'll do. And to handle the odd case, so you might think, well, 1221 is really easy. We flip the 1 and the 2, and now it's 1 is concurrently checked and 2 is concurrently checked. That's great. What about the odd case where it's 1, 2, 3, 2, 1? We need to basically give a free pass. We need to give a free pass if one of the pointers is pointing at a null. So 1, 2, 3, and then we'll flip 2, 1. So I have 1, 2, 3 compared to 1, 2. And I'll say, oh, they're both 1, they're both 2. Well, this is a 3, but that's a none, and I'll give that a free pass. And that solves the odd counted problem. Does that make sense? If that made sense, smash the like button. If that made sense, share the video with your friend who codes or wants to code. So approach, use fast and slow pointers. Flip the second half of the list in place. Concurrently compare. First and second half of lists. Free pass when comparing any symbol to a nullish value. I don't want to say a nullish value. I want to say a null value. Time complexity is O of n. Space complexity is constant, aka O of 1. I had a typo somewhere. Space time complexity. Okay. So here I'll make a fast, which is pointing ahead. And I'll make a slow, which is pointing ahead. I'll say while fast and fast.next and fast.next.next. I'm not sure if stepping twice will create a problem, so we'll have a to-do there. So while fast is allowed to step twice, it will do so. I think it needs to step twice. I think I can just delete my to-do, but we'll leave it there anyway. I have some vague memory in the past of that being problematic. Or maybe someone said it was problematic even though it wasn't, and it just stuck with me. Okay, so now slow is at the midpoint at this time. Second half flipped list equals So here I want to flip or reverse linked list. I love this because it's such a meme that you ever need to reverse a linked list because you never do that in real life. But here it's being done in Leetcode. And this problem is not like real life. So this is not canceling the meme. This is just like enshrining the meme that it's a ridiculous Leetcode thing to do. So we're going to pass slow because that is going to be the top of the second half, which will allow us to flip in place. And it will return the second half flipped list. Now we'll say first half. Let's just call this first half node, and that's going to equal head. We'll call this second half node. And then here I'll say while they exist. And if either one of them goes null, we'll just exit and that'll be our free pass. To do. And here, if we get down here, we are going to return true that it is a palindrome, because here we will falsify it. Okay, how are we going to falsify the palindrome? We'll say if the values are different. Remember, I want 1 and 1, 2 and 2, they need to be the same. So if both values exist and they are different, that's how we're giving a free pass to the none. So if they are different, then we'll return false. And if we get all the way through our while loop and we never return false, then that means we traversed concurrently down these. Oh, I also need to do the traversal, right? Then it will mean we can traverse concurrently down these. And we never falsified it, so it is a palindrome. So here's the actual traversal, is that next statement. We're moving those pointers. You passed on this check. Boop, boop, boop. I think it's VAL. Let's double check. VAL, yep. Okay, this looks good, except that I have no reverse linked list. By the way, this is how I recommend you implement your solutions at interview time. So you lay out the structure here, and maybe you have some early design discussion. We did that, right? You have that discussion with your interviewer, get permission to proceed. You can start coding. And even if my interview was cut off right now, they would be able to see that I had the right idea. They would say something like, he had the right idea, he had the right complexity, it was the design was pretty optimal, he was just slow. And that would be, it's not like good to get cut off. It would be better if you can successfully implement, but sort of if you're going to have negative feedback, this is among the least damaging kinds of negative feedback that you can have. It's like he thought the right things, he was just a little bit slow. That's my 2 cents anyway. I don't know. Run a poll with your interviewers. I mean, I have been an interviewer, and that's my take as an interviewer. Some interviewers will have different opinions, but I think mine is quite common. Quite common. I have not actually run a survey to see if it's the majority, but just ask your folks, ask your network. I'm going to run a poll on that after the stream. Now that I've thought about it, let me make a note of that. Let's do a poll right now before I forget. Why not? That'll be fun. Okay. Palindrome linked list. Now I need to reverse a linked list. Let's do it. So we want to pass the self argument because we're on this class. And then we want to have a head node. This is the before reversing head. Pre-rev head. Okay. We are going to have a last pointer, which is set to none, and we will eventually return last. Why do we do this? In a forward list, ABC terminates in none, right? So this is my forward list, ABC none. So when I flip it, none will always be the last pointer that I want to stitch to my pre-reversal head. Because we want that ABC, we want to flip it so that it's CBA, and then after A is none. That will always be the case. And then CBA, whenever I return, I want to return C. I want to return C. A, B, C. Yeah, I want to return C. When I go ABC none, the current pointer will be at none, but my previous or last pointer will be at C. And so that is the one that I want to return because it will be the head on the reversed. So that's why we always return last. It's often called prev or previous, prev, whatever I'll call it last. And so what I want to do is I want to say while cur node. And I can even do this in place. I could do while pre-rev head. I could do that, but then it gets weird because I'm pointing at different things with it. So I'm going to initialize a cur node, really just for readability. And cur node will be set to here. Okay, and then so we will be traversing via cur node. We'll be traversing via cur node. So cur node is cur node.next. Here's the problem. I want to set cur node.next to last. That's how I flip my pointer. That's how I do the linked list reversal. So I want to set my cur node.next to last. Now I can no longer use next for forward traversal on the original list. I've basically implemented a circular loop. So I'm going to go forwards to the previous node, and then I go forwards to the previous node. That won't work. So what we need is we need a temporary variable that will be an escape hatch. It will allow us to basically teleport out of the infinite loop we created. So you could call this, you could call it whatever you want, teleport, escape. I'm going to call this cached next. Why do I not just call it next? Because next is a method, a global built-in method in Python. So I'm going to call this cached next. And that's going to be cur node.next. And so at the end here, cur node is not going to next, it's going to the cached next. So I repoint my next pointer at the old one, and then I just jump to what it would have been before my stitching, okay? So did I complete it here? No, I need to do one more thing. I need to update last, and that will complete the reversal. So last was previously none, and now that none has been used. So what is the new last? The new last is the current node before my current node traverses away from its current position. Perfect. I think we're good to go. No attribute next. Did you mean next? Yes, I did. Thank you. Okay. And that's how you do an optimal palindrome. Optimal palindrome. In terms of memory complexity, you can see the time is slower than if I had the giant map of seam nodes, then my time complexity could be linearly faster. The complexity actually wouldn't be faster, but the wall time would be faster at the cost of a bunch of memory. Very common trade-off. Spam it with memory to get your performance up. Very common trade-off. But in this case, time complexity, space complexity, this was a W. Where are we at? Let's go to clone graph. Number 6. Okay. We will erase the prior implementation. And I kind of cheated because I saw that there's going to be a DFS. Oops. But yeah, trust me, bro, when I say that I would have thought of doing DFS anyway. Okay, thanks for the likes. If you're enjoying the video, hope you'll smash the like button. Share with a friend and consider joining latterly.io for free, where we can help you prepare for interview if you're interested in a coding interview. So given a reference node in a connected undirected graph, why does it matter that it's connected rather than disconnected? It means that we can do a clean DFS. What do I mean by a clean DFS? There is a guaranteed origin node that will allow traversal to all other nodes. So it's a singular tree. So I can immediately return DFS. Because it's connected, I can immediately return DFS. If it was disconnected, I could still use DFS, but I wouldn't be able to immediately return it. I would need all of the origin nodes for all of the trees, and I would have to run DFS on all of them. This would be something that's something that happens. It's something that happens. Yeah, I ran into an interview problem like that recently, where it was a disconnected graph, and I thought, oh, disconnected, I'd better use BFS instead of DFS. And the interviewer said, well, you could use BFS, but you can also use DFS. I was like, oh, I guess you can. You just have to run DFS multiple times if it's disconnected. But if it's connected, you can immediately return it. So there's no need to loop over the topologically first nodes. Okay, so given a reference node in a connected undirected graph, let's return a deep copy or a clone of the graph. Deep copy means that I instantiate new nodes, and you can see definition for a node is given. So I have to actually create new node instances using this class instead of pointing to nodes. That would be shallow. That would be a shallow copy. If I just returned like a tree of pointers. So I don't want to do a tree of pointers. I want to do a tree of node instances, which means that I'm going to basically be using O of n memory complexity, space complexity. And we're going to be doing O of n at a minimum time complexity, because I need to explore every node in this graph. I need to explore every node, and I need to make a copy of those nodes. So you can see that I'm going to be doing at a minimum O of n. That's pretty much the whole prompt. The test case format is weird. So this is like a Leetcode technical note sort of thing you can see down here. It says output, this is the output, but these numbers here are for the neighbors. If you look on the node class, lines 1 through 6, these are for the neighbors, not the values. And then how do you know what the value associated to the neighbors are? Because they're in order, 1, 2, 3, 4. So that's just like a weird thing about the Leetcode test cases, but really this is the prompt for the problem. Okay, let's dig in. So what am I gonna do here? I'm gonna return a DFS, and I'm gonna pass in my node. Since I have a singular head node, I'll return node, if node, else none. Again, line 19 is optional, so there might be no node at all. If there is no node, what is the clone of none? It's none, okay? And none is just the Python null. So Java, this would be like a null. Or really like almost every other language, like JavaScript, whatever. Thomas says, is this a rebroadcast or is there another chat John is responding to? Hey Thomas, can you hear me? I think I'm live. I don't think I'm rebroadcasting unless something weird is going on. Another chat I'm responding to, I mean, yeah, we got some folks from LinkedIn. I don't know if they're still on, but previously they were. And there's a bunch of people on TikTok, but unfortunately I cannot see the comments. So if you've recently joined the stream on TikTok, thank you for being here. Please tap like and follow. But if you would like to drop a comment, please visit my bio and head over to YouTube or Twitch. You can also consider joining ladderly.io, join the Discord. It is in the upper right, the community tab. You can join the Discord and add your comment there. Because for whatever reason, I'm not able to see the TikTok chat. That really bugs me. Anyway, I'll not be going down that rabbit hole. I don't know why that's going on. Okay. So what are we going to do? We're going to do a DFS on this node. What is the DFS going to do? The DFS is going to look at all of the, let's see, neighbors. It calls it neighbors, not children, which is kind of weird. But from an information architecture, like tree navigation perspective, they're basically children. So we have this node, and we're going to look at all of our neighbors. And we're just going to create clones. We're just going to create deep clones, new node instances. The caveat is that two neighbors can be connected to each other. That's the thing that's tricky here. So that is why we need a processing node map. Processed. So here will be node, and we're going to say, hey, if you've already been processed, we'll just return that. If node if the node's in there, we will return it. So we're guarding our logic by checking if it's already in process. That allows our DFS to it allows our DFS to terminate. It allows our DFS to complete. Otherwise, our DFS could have an internal cycle where like two neighbors are processing at the same time and they keep talking about each other. So the way we avoid that is it's just like whoever got here first, basically. And you say, oh, well, that's over there. And you point back at that existing node with a guard before continuing to do this additional logic. And so what will the logic be? The logic will be create node neighbors using DFS, and then return clone. Yep. We need to attach the clone. We need to attach the clone. Attach clone before calling DFS, which allows us to do our escape hatch. So what's the clone? The clone is a new node, and the value is going to be node.value. Does that make sense? This is a new instance that is cloning the value of the old instance. Then we're going to attach it to the process node map. Okay, so the clone is the value. And you can see if we run into it again, it will be eagerly returned with this same process. Now what we want to do is for we want to call DFS on all the neighbors. For in node.neighbors. For in node.neighbors, clone dot. Yeah, we can do it that way. I think this is going to work. So we'll initialize neighbors to an empty array, and then we'll say clone.neighbors.push self.dfs. If this doesn't work, we can make like a temporary array and then attach the whole array later. But I think this should work. Self.dfs of in. Okay, so now we have the clones of all the neighbors, theoretically. And now I could update the clone over here, but I shouldn't need to. Because it's done by ref. To do is neighbors by ref bad. So if there's an error, that's going to be my first suspect, but I think it should be fine. When I am interviewing, I do like to leave myself these comments. Sometimes interviewers pause me, which I try to resist, but sometimes interviewers will pause me and they'll say, hey, like, don't run the test. Like, what do you think? Like, do you think it's bad? What I prefer to do is run the test and see. But if you pressed me, if you're like, I don't want you to push the run button, I want you to tell me what you think. I'll say, I think it's just fine. It's like a just in case sort of thing. So I leave myself future looking potential debug candidates. I try to leave myself those as I go along. And I do try to expedite the interviewer. If the interviewer tries to pause me, I'll say, hey, like, we can just remove the comment if you want. This is more like a mental note. I think it's going to be fine. But if we end up having to debug, this would be a candidate that I want to refer back to. So it should only take me like 5 seconds to overcome that attempted pause. Oh, I didn't put self on the DFS. Self. Process node map. What's going on here? Dun, 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 dun. There's a key error. Oh, yeah. So if the node's not in the map, that's generating a key error. So instead, I want to use get, which will find it if it's there, and if it's not there, it will return none, and it will exit my if. List does not have push. What is it, append? Cool. All right, that worked. Looks like the performance is pretty bad. I wonder if that's using ByRef. Like, why would attaching a new one be faster? Oh, and now I'm beating 90%. I guess there's just a lot of variation in this question. That's crazy. Sometimes it'd be like that. Okay. Clone graph is down, feeling good. Starting to need a bathroom run. Course schedule, let's take a crack at course schedule. Okay, so I'm going to Command Shift End, enter. Put this sort of to-do marker, the ellipsis in Python is like a pass. Okay. Thank you for the likes on TikTok. Thank you for being here. Almost over 1,000. I see comments coming in, like I see a counter, but the problem is I can't read them. So if you're on TikTok, consider visiting my bio and going to Twitch or YouTube. I'm not sure why I'm not able to read the comments today. Over 1,000 likes now. Thank you so much. And if you're on another platform like a YouTube or a LinkedIn, I hope you will tap the like button and follow on that platform as well. Thomas says, I remember doing one a lot like course schedule as homework in college. Nice. Yeah, I got an interview problem that was a lot like course schedule recently. So the problem reads, there are a number of num courses that you have to take, labeled from 0 to num courses -1. Seemingly indices at a glance. You're given an array of prerequisites where the prerequisite of I is AI, BI. It indicates that you must take BI in order to take AI. You must take BI in order to take AI. For example, the pair 0, 1 means that in order to take 0, you have to take 1. Return true if you can finish courses, otherwise return false. And an example would be example 2, where there is a irreducibly complex dependency. Irreducibly complex dependency. So you cannot take 1 because 1 requires 0 and 0 requires 1. I guess they don't allow concurrent enrollment at this school. Okay, so how do we want to approach this? I'm not sure. So I feel like I want to use BFS, but if you ask me why BFS and not DFS, I'm having difficulty constructing the tree in my mind. So let's say that we aggregate the prerequisites. So currently, prerequisites of I, AI, BI, okay? But now I want to reshape that structure because I might have multiple records. Might have multiple records like AI, BI, AI, CI, AI, DI, and I really need to take B, C, and D in order to take A. So A has multiple dependencies. So I want to merge these records. So I'm given the unmerged prerequisite adjacency list, and now let's try to merge them. And so now that I have a merged adjacency list, how do I proceed from there? I could use BFS or DFS. I think I can use either one. And I am not seeing an advantage or disadvantage to either one. Maybe the DFS recursion would be easier to write. Maybe it would be easier to implement. So I will say that I will use BFS or DFS. I think the complexities will be the same in either case. The structures will just be different. So I prefer to start coding and then see if I need a queue or not. Thomas says it's basically a graph question, right? Saying there are no cycles. Yeah, it's basically a graph question. But we cannot treat this similarly to the linked list find cycle. This is not going to be similar to the linked list find cycle. Even though it's cycle detection in a tree traversal. So the implementation is different. Okay, so I'll say intuition, I can use BFS or DFS. I will want to merge dependencies to create, which requires O of n space complexity. So if I merge the dependencies, and then what do? I will just run through Okay, so in the worst case, every course depends on another course. There are 2 courses to take. What if there were 10 courses to take? In the worst case, every course depends on another course. I need a scene map to avoid cycles. Also ON space. So is it going to be ON or ON squared time complexity? It's going to be one of those. It will be ON or ON squared time complexity. In the worst case. Okay, so in an ordinary tree, I can DFS and O of N. In an ordinary tree, I can DFS and O of N. The problem here is the potential of a cycle. Problem here is the potential of a cycle. And so let's say that there is a cycle. If there is a cycle, I don't need to run the tree again. I just return false. So it should be O of N. It should be O of N time complexity, because if there is a cycle, I just return false. I don't rerun the tree. Dennis says, are you following a list of problems? I noticed you solved this one before. The answer is yes, Dennis. So this is the Latterly Leetcode Kata, blog article number 3 on the Latterly blog. We are currently on problem number 7. And this is part of a Leetcode Marathon. We'll be getting all the way through 12, and then we will go over to the Leetcode 150. And then maybe after the Leetcode 150, we may come back and do the expanded kata. We'll see. We'll see. This marathon is going to be comprised of multiple streams, 2 at a minimum, and quite probably 3 or 4. So I think when I get through course schedule 2, that'll probably be the end of the first stream. We'll see. The stream will be saved. This is notable. The stream will be saved on my YouTube channel. So here you can see we're currently streaming to YouTube. And if you go to the live playlist, the Leetcode Marathon will be available to you as a saved copy. And there will probably be Leetcode Marathon Part 2 and Part 3. Maybe more than that, or maybe that's about it. Also encourage you to consider this recent stream on networking tips. So Leetcode is going to be super helpful once you land the interview so that you can progress through your coding round and then through your final loop. But we know that that's not the whole story. Behavioral is really, really, really important, especially at the senior level. System design, very important. And also, getting your first interview is extremely difficult in this market. So the networking tips Q&A, I think that went marvelously, and that will help you get your interview. So I would kind of consider the Leetcode Marathon really important, but really a second stage after those networking tips. Lots of good stuff on the live tab here. Check it out, and there's also really cool playlists. Ari says, would you mind giving a high-level differentiation of DFS and BFS, maybe once an hour or so? I don't know that I'll remember to do it once an hour, but I'm happy to do it now. And then if you remind me, I'll do it whenever you remind me. So DFS will use recursion to enqueue calls on the memory stack itself. So DFS uses recursion. BFS is an iterative approach that uses an explicit queue. So you have literally a queue that is like a list, for example. You can do it other ways. But I could say for item in queue, and I would start with some initial course, and I would do some logic, maybe add more stuff to queue here. So this pattern is a BFS. And the giveaway is the 4 item in queue. Really there's 2 giveaways. The queue existing at all is a giveaway that is BFS, not DFS. Because in DFS, you're using the memory stack, the actual built-in language process queue, instead of an explicit queue. So DFS would say, return DFS initial node. And there would just be multiple calls collected on the execution queue for your language instead of an explicit queue in your code. Does that make sense? You're going to use that memory either way. It's just where do you put it? One of the benefits to DFS is the implementation often requires fewer keystrokes. It's easier to write because you don't need to explicitly make a queue. You don't need to always do a for loop, although sometimes you do. In a disconnected graph, you might need a for loop because you might need to call DFS more than once. But the typical benefit to DFS is going to be that you can implement it quicker. That's the justification given in Leetcode style interview settings. But it also has a ton of drawbacks, and those are the reasons that you don't really see it in commercial code bases. The drawback is that if you misimplement it, it can generate an infinite loop or an out-of-memory error or a timeout. So in commercial settings, you will generally see a BFS, like an explicit queue. Also, the queue being explicit is an advantage in a commercial setting. Las estás? Thank you. Tina just brought me food. Thank you, Tina.
Hi.
Did that make sense, Ari? In terms of the differences between BFS and DFS, one is going to have me writing an explicit queue, and I will explicitly enqueue and dequeue. And then the DFS will do it implicitly, which makes the implementation easier. It's a bit more dangerous in a commercial setting, but it's generally preferred in a Leetcode interview setting. But the time complexity and the space complexity between the two should be equivalent. It's just a matter of a different implementation. Omkar says, I want to do Leetcode, but I get bored doing it alone. So can we do it together on the stream? Like while you doing it on the stream, I'll try solving too. Yeah, sure. We can do a pair stream. Yeah, do you want to do some of the problems right now, or do you want to actually join the stream? So I won't have you on the current stream in the middle of the stream. That's weird and tricky to do. But we can do another stream later, either a different day or even perhaps later today. Or just as a member of the audience, you can just sort of follow along, let me know where you're at, and let me know where your questions are. All right, can finish. So what have I said here? What I've said here is it should be O of n time complexity. Because if there is no cycle, I just return false. I don't rerun the tree. But I do need to see every element in the tree schedule. Okay, so there's the complexity analysis. Ankar says, do you stream regularly? I'll solve along while watching you do it. I stream Monday through Friday at 3 p.m. Eastern time is my standard schedule. This marathon that I'm doing currently is non-standard, so I'm gonna have extended hours during this marathon. But typically Monday through Friday, 3 p.m. Eastern time. And then Tuesday, Thursday, Saturday, I do an evening stream, which is 8 to 9 p.m. Eastern time. Okay. I feel like I'm stalling, like I'm doing this really slow. So can finish. I want to merge dependencies. So I'll call this merged. This is going to be some function of the adjacency list. Here I'll start with an empty list. and I will say for prereq in prerequisites. No, let me not use this merged list this way. Let me use this merged list this way. So the key will be A, and so we'll call this blocked equals prereq 0, and then blocker is prereq 1. Okay, so merged blocked, say if, we will get it because it may not exist. So if it's there, it's going to be an array. And if it's not there, we will set it. We are growing the list of dependencies. Blocked dot append. Maybe I want this to be a set. Add. So if it's there, we will add blocker. Else, we will set it to be a new set that includes blocker. Okay, so now we have this dictionary of merged dependencies. And so now what I want to do is for course in merged, what I need to do. What I want to do is I want to complete all of the courses that have no blockers. I want to complete all the courses that have no blockers. So how do I know whether you have a blocker? Well, in the past, I've typically used an in degree for this, counting the in degrees. But in the current implementation, that seems a bit strange. Ankur says, are you trying to make a dictionary that stores course as key and the prereq of each course as a value? Yeah, that's what merged does. That's what merged does. Thomas says, I don't think you need to know about things without blockers. I don't think you need to know about things without blockers. Yeah, that's a good tip. That's a good point, Thomas. Matthew Sabu, I just had a question about your course. Basically, you give us a checklist of stuff to complete, but are there videos that come with it for us to learn these or no? Well, it's not a course, it's a checklist. So it's not that the course gives you a checklist, it's just that it is a checklist. So Latterly does not actually have a course. Are there videos with it? So for example, if you click search techniques, that would be a video. So the answer is that sometimes there are videos and sometimes there are not. I feel fairly confident in HTML does not have its own video. Understanding user settings is just a blog article. So sometimes there's going to be a blog article. Does that make sense? Okay. Maybe I should just make a proper course already. It's a lot of work to do though. So for a prereq in prerequisites, we have these sets of blockers. What about for each course? So for each course in merged, I want to know whether the elements of your set have been satisfied. Whether the elements of your set have been satisfied. Oh, and they're going to be labeled from 0 to 1. This is actually quite interesting. So the course, we'll call this course ID. Course ID and merged, and they are in indexed order. So the course ID is a course index as well. So up to the current ID, is satisfied or no. So this is where I can do a DFS basically for course ID and merged. How do I know that you're done? 1 and 0. Here I will have key of 1, value of 0. I think I need to collect the completed courses, do I not? Do I not need to collect the completed courses? Or by the time I even get to 1, yeah, so the first I would hit 0, and 0 depends on 1. So can I just deduce by the fact that 1 is greater than 0 that it's not yet been completed? So 0 can depend on 1, and 1 can depend on 2, and 2 can depend on nothing. So I can't deduce it that way. I cannot deduce it that way. So I need some other store of completed courses. Right, so if I use DFS, I'm going to need to add memoization. If I use BFS, I don't think I need to. So we'll call this scene. We'll call this scene. And completed, I'm not sure I'll need this, but let's just see. We'll have seen and completed. For course ID and merged, running DFS on all of them is fine because I have memoization. So I can just run DFS, and this is going to be return true if you can finish all courses, otherwise return false. If, so here I'll say can finish is my DFS. If not, can finish, return false. otherwise return true. Let's see about this. Let's see if this works. So when I call DFS, I need to pass it merged scene completed. Merged scene completed. Anything else? Course ID. I think that's everything I need to pass it. We also need to say that this has been seen now. So scene of course ID is going to be what? Maybe it will be this DFS. Scene of course ID. Let's give that a try. I'm not sure about that. Okay, so we will basically say, hey, I've seen this, okay? That way I don't have a internal cycle in my DFS. It will return the ongoing calculation. So that's the first thing I need to do is guard it. So if, oh, let me pass my arguments. So I'm passing my arguments. So the first thing that I want to say is if you have been seen, then we will return whatever it is. If you've been seen, we'll return whatever it is. Otherwise, if your dependencies are incompleted, for dependency and merged, oh, also if you're not in merged at all. If not merged dot get. So we'll call this deps. Merged dot get course ID. So if not deps, we can return true. Okay. And then otherwise for dep and deps, can complete if not seen course ID. If not seen course ID, we can return false. So really, I can just return that. Oh no, I can't return all of them. So what is this? I need to collect them. Can complete for dep and deps. We will call DFS. And then see if they're all completed, basically. See if they're all completed. So there's two ways to do this. I can check they're all incompleted, or I can collect like all children completed. All children completed. So that's like a pseudocode. It's like a pseudocode. Yeah, they're pretty equivalent as far as I can tell. So I will do this twice. We're gonna call DFS, and then we're gonna loop on them again and see if they've all been completed. So for dep and deps, we're going to call DFS, and then for dep and deps, if not, yeah, so we can just go ahead and return true here. I don't even need the all deps completed. So we'll run DFS. Ooh, and then now I can see how I can combine them. I think I can combine them that way. Now, what's missing? Something that's missing here is that I have never marked course ID as seen. Can I just do this? I'm placing this thing onto scene incorrectly. Why did you put set to add prereq in the merged? Oh, I don't know. Just the edge case in case prerequisites has duplicate entries. So like 0, 1 repeated 5 times, I wanted to reduce them. Let's see, I'll give this 5 more minutes and then I'm going to time box myself. So something is wrong about the way that I'm saying that course ID has been seen. What I need to do is I need this entire collection to be inside of the DFS thread. so that I can return the result of the entire collection. See, maybe I can just do this. So for course ID and merged, self DFS, and if you ever get down here, we'll return true. Okay. The thing that I'm worried about is assigning a primitive to the scene value, because will it end up short-circuiting it properly? All right, let's give it a try. I'm not sure that this is okay. I'm not sure that that's okay, but we'll give it a crack, and if it doesn't work, then we'll time box. Anchor, but I think it will throw an error because it's only an int and not iterable. I'm not sure what you mean. If I am iterating over an int, then I wrote a typo somewhere. That was not my intent. Okay, so scene course ID is false, and then eventually scene course ID will be all depths completed. Okay, and then we will return. So we're going to do some calculation and then return. LinkedIn, hey John, I saw your comment with Reagan, noticed you were live. Welcome, welcome. So we're temporarily assuming that it's not going to, this might be illegal, but let's give it a shot. And so now what I want to do is for dep and deps, I will check all of them. Let's assume this is true. Yeah, I think I can just do this. I'm not sure I need this additional variable. So we're going to assume that it's false, but if you get all the way through dependencies, then we're going to say, now you're true. Now you're true. Let's see if that works. I don't know. Int is not iterable. Where are we at? Line 20. Merged blocked is set blocker. Is this saying I can't have a set of integers? New set. New set dot add blocker. Okay. So why did the maximum recursion depth get exceeded? Remove set, I believe it's not needed because in dict you cannot add multiple same keys anyways. So the justification for adding the set is not that there would be duplicate keys, it's that there would be, we are merging. So it's called merged. So I can have a prerequisite that's like this. 0, 1. Two, 2, 3, 4, or 5. Yeah, I can jump to 5. That's fine. So does that make sense? That's the reason for using this set. Is not because the zeros will be duplicate, but to merge 1, 2, 3, 5. That's the purpose. Interesting that I didn't end up using completed at all. That's kind of cool. So prerequisites, num courses. Let's step through this. Num courses is 2. Oh, I didn't use num courses at all, huh? That should be a flag that I'm doing something wrong. So what is the num courses for? There are a total of num courses you have to take. Labeled 0 to num courses minus 1. So I said for course ID and merged. What I should say is for course ID and range num courses. I'm not sure if that fixes anything. Yeah, I don't know. I'll take this over to GPT and then I will view the solution. Oh, there's an interesting constraint. All the pairs for prerequisites are unique. So that eliminates my concern about O2, Consider this Leetcode prompt. Is it okay to ask questions that are non-relating to Leetcode? Sure. You can also go over to the latterly.io Discord. I will be pausing the stream soon and we'll be picking up the marathon later in another episode. You can always visit latterly.io, visit the Discord, and drop your questions there. Okay, it's like giving the answers. Hold on. What is wrong with the following approach? I get recursion depth exceed. Recursively calls itself with the same course ID. Oh, okay, that'll do it, won't it? Yep, right there, that's wrong. So that should be saying dep. Okay, so in this case, I return false. The good news is that there was no recursion depth exceeded, so I guess assigning the primitive is okay for breaking the infinite loop. That's good. So here, I return false, and then we'll step up the DFS. If not false, return false. Yeah, if not false, return false. So then that should ultimately return false, eh? mark this course as seen, uses that primitive as the marker. Completed, if course incompleted, return true. So is completed needed. It's not strictly necessary, right? So merged, we merge it, great, seen is over here, okay. If course ID and seen, if course ID not and merged. Ooh, this bit is maybe what I'm missing. If course ID not and merged. Yeah, it does this depth thing differently. Oh no, that's just a different way to write the same thing. Okay, fine. So that's the same, mark it, and then what does it do differently here? If seen course ID true, return true. So let's see if this even works. It looks like what I did. That was accepted. That was accepted. Okay. What is the diff between what GPT did and what I did? Let's use my solution with its DFS, and maybe that fixes things. Here, I'll get rid of completed. Completed didn't help us, we found out. Because the completion data is included in scene itself. And yes, we can move scene into the algorithm body, which is nice. So you can move, we have merged and seen, okay? Maximum recursion depth exceeded. So my scene is passed in. So it's using a dictionary instead of a set for merged. Merged, blocked, blocker. Okay, John, I got to go. I joined the Discord. We'll chat there later. Thanks. See you. Using a set is appropriate and does not cause an issue in this context. Well, I didn't mean to use a default dict, but okay. Now it's called graph. I like my name merged more than graph, even though merged really is a graph. What is this complaining about? If not self-DFS. for depth in depths. Oh, and here we can just say if depths, I think. Return if depths, and then otherwise return true. That's nice. If there aren't any depths, we just say that we saw it and it was true. I can move this up. Move that up. And I really don't need if depths, I can just say for depth and depths. That requires the default dict thing. Because for depth and none doesn't make sense. So, what am I missing? What am I missing here? Merged scene dep. Dep is going to be a course ID. Yeah, I'm still missing it. So it gave me a working answer, but I'm not seeing the difference. Highlight only the bugged code, don't provide a full answer. What's wrong with the below? This should be dep instead of course ID. Oh, did I still not fix it? If course ID and merged. For course ID and merged. No, I already changed that. Marufa, how to be a good problem solver. Practice, 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 practice. And don't give up. And be nice to people. When I say practice, practice on problems that are at the limit of your current capability. So do difficult things. Don't just practice on the easy problems all day. So let me copy this DFS bit here. So does mine work except for the DFS? So we'll call this old DFS, and then we'll make a DFS right here. No. Merged scene dep. Merged scene dep. Okay, so this DFS is good. So we need to contrast these two DFS. So the first thing is a guard clause. If the course ID has been seen. So I say if the set is there, return the value. They do similarly. They do similarly. Except I don't need to get. I can just say if course ID in scene. I like that better. So if course ID in scene, return the course ID of scene. Great, so the guards are similar. If the course ID is not in graph, where I say, mine's more convoluted. If the course ID is in graph, so I'll say if course ID in merged, if course ID in merged, maybe that. I think that's a little simpler. So if the course ID is in merged, if the course ID is in merged, then for each dependency we'll run DFS. And they say if course ID not in graph, scene course ID is false. If course ID not in graph, return true. That bit is missing. Course ID not in merged, return true. If course ID not in merged, yeah, I think that should be fine. So let me use their DFS. If course ID not in graph, return true. Let me move this up. That's still okay. So you can set the scene higher. We can set the scene higher. And then here, I can say if course ID in graph, and I can indent their solution. And that's still okay. That's still okay. So these are getting to be very similar implementations now. Scene course ID is true, scene course ID is true. So the difference is in these 1, 2, 3, 4 lines. Course ID in graph. For dep in graph ID, for dep in graph ID. If not self DFS, if not self DFS. Really, really, really looks the same to me. Okay, so somewhere I made a minor adjustment to mine that fixed it. What did I do? Something that appeared minor anyway. Deps merged get course ID. Let me copy this good state. I'm going to copy this good state. And I'm going to rewind until it fails. I'm a second semester CSE student. I love to do competitive programming. Could you please give me some suggestions? Sure, yeah. Check out the Latterly Leetcode Kata, latterly.io. Check out the blog and go to article number 3, the Latterly Leetcode Kata. You might get bored of the kata as a competitive programmer. You may complete it and then get bored of it. That's fine. It's mainly for interview purposes rather than recreation. But still, I think it's a good starting point. If you want to go further, there's an extended kata with 20 problems. And then further than that, you can go up to the Leetcode 150. That would be where to go from there, basically. Okay, so I'll keep doing Command Z. Until I see a failure. So at this point, yeah, at this point I see a failure. Command Shift C. That works, Command Z. And that fails. So now I'll paste. So now I have my modified DFS. So I have my modified DFS, I have GPT DFS. And then here's old DFS. So here's DFS, this one should be failing. This is failing. This one is passing, okay. Let's just confirm one more time, this one is failing. Good, and I'm gonna literally do a text diff on them, because I am not seeing what the difference is. Oh, that's cool. TikTok Studio is hijacking my keyboard. Okay, so obviously the name, and then I think this bit right here doesn't matter. So I'll just confirm that. What? Oh, that was it? Okay, something I'm not understanding here. If course ID and scene versus if scene.get course ID. That's the critical difference? No, I really don't understand that. Why is that the critical difference? So this fails, and this works. Whoa. Let's ask GPT. It seems that the critical difference is because it returns false when the course is, oh man. Yes, it's not a syntax difference. When I was confused because I think those syntaxes are equivalent. But it's actually pulling the value, and that value, the marker that it has been seen, the value is false. Okay, so maybe the note to self is really just avoid doing a .get. Like the end scene seems like a safer pattern in general. Okay, all right, well I can feel content that I see the root cause of the problem. Thanks for being here. That concludes the first part of our marathon. When we pick back up, what problem is this? Course schedule? I'm gonna pick back up, I'm gonna do course schedule again, and we're gonna do it until I get it right. And then we're gonna basically try to proceed and get through the rest of the 12, and then start on Leetcode. We'll see how far down Leetcode we can get today. But I'm looking forward to it. I hope you'll follow the page. Thomas says, here was my attempt. That looks pretty cool, man. I don't know if you're comfortable with me sharing your content, but for a note for the future, if you join a stream in the future, and if you want me to share your solution, I'm more than happy to, but I'm not gonna assume that you want me to share it. But that is a good looking solution. Thank you for being here, y'all. And hope you'll follow the page, and I'll see you next time.